Bismillahirrahmanirrahim. Welcome students. Today we are going to discuss about alkynes. Alkynes, the term alkyne contains "-ine", which represents triple bond in carbon compounds. The simplest alkyne is acetylene. Alkynes are also called as acetylenes because of the first member, acetylene. The molecular formula or the formula of acetylene is C2H2, means 2 carbons, 2 hydrogens. Now let's see, alkynes are also called as acetylenes. Why? Because the first member of the alkyne is acetylene, so the first member of the series is acetylene, so they are acetylenes. Alkynes are acetylenes. So alkynes are having triple bond. Now, occurrence. Where do they occur? Acetylene, let's see the first example, acetylene, or you can say commonly acetylenes don't occur or does not occur free in nature. It means they are in the form of combined state because of they are reactive. Because of triple bond, they are reactive, so they don't occur free in nature, they occur in the combined state. So little amount, traces of acetylene are present in coal gas, about 0.06%. Now if you go to the next part, preparation of alkynes, how we are going to prepare alkynes. The first process is dehydrohalogenation of vicinal dihalides. Looks like very big term. Let's see. D means removal, hydro comes from hydrogen, halogen comes from halogen. So halogens, all the 7th group or 17th group elements like fluorine, chlorine, bromine, iodine. So it's a process of vicinal dihalides. What is vicinal? Vicinal means adjacent. Dihalides, di, 2, halides comes from the halogen. Now let's see. 2 carbons having hydrogens and halogen. If you consider this as first carbon, this is second carbon, when this compound reacts with potassium hydroxide, see here, if nothing is here, means here it can represent this part, we can take H or we can use R. It means we can use hydrogen or we can use R. It's a general form of the equation. Now when this potassium hydroxide reacts with this compound, what's happening? Look here. This hydrogen is out. See here. And this halogen is out. See here. So one hydrogen and one halogen is out. One hydrogen, one halogen is out. So now what is left? One hydrogen here it is left and one halogen is left here. So when this part and this part is out, out means they are removed, they are going out. This is called as D, dehydro, dehalo, so called dehydrohalogenation of vicinal 2 adjacent carbon dihalides. So this is having 2x because of here 2x is called as dihalide. So what happens here, one element, the x from here, the h from here goes out. Due to this, from single bond it is going to form double bond, and this K and this X, they react and form to form potassium halide, and hydrogen and OH, this hydrogen and OH, they react to form water. So now if we go to the next part, before going to the next part, let's see, when a vicinal dihalide, this is the vicinal dihalide, is heated, means is heated with potassium hydroxide. 2 hydrogen atoms along with 2 halogen atoms are removed. In the next step, on continuation, the leftover hydrogen and this halogen also get removed, and here 3 bonds will form. Says 2 adjacent carbon atoms with the formation of triple bond. In the next step, these 2 will form into 3 bonds. Now let's see here. Dehalogenation of tetrahalides. D means removal. Halogenation, removal of halogen atom of tetrahalide. So tetra means 4. Halide comes from halogen. Bromine, 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 bromine. How many bromines? 4 bromines. 4 means tetra. Because of their bromine is halogen, tetrahalide. Dehalogenation means removal of these bromines. So when this compound with 4 bromines, R indicates alkyl group. Alkyl means either it may be CH3 or C2H5 or something else. Now here it means on the continuation of the series. This compound in the presence of zinc and also in the presence of alcoholic liquid, it means alcoholic potassium hydroxide. Actually we take here alcoholic potassium hydroxide in the presence of zinc dust. What happens? These bromines, they are removed. When the bromines are removed, in between here you can see single bond is there, right? This single bond, because of bromines are removed, here it forms triple bond. Why it forms triple bond? How it forms triple bond? If you see, each line indicates 2 electrons. Each line indicates 2 electrons. When this bond is broken, bromine takes its electron and goes out, and here 1 electron of this comes here, 1 electron of this comes here, means double bond. Then here 1 electron of this and 1 electron of this comes, 1 bond. So total how many? 3 bonds. So you can see 3 bonds. So this triple bond compound is alkyne. We can't give the name because of R, alkyl. So just commonly we can give it as alkyne. Now next, this zinc, remaining bromine, all the bromines, they react with the zinc and forms zinc bromide. It's not balanced. If you write is 2 here, it gets balanced. 1, 2, 3, 4 bromines, 2 times 2, 4 bromines, 2 zinc, 2 zinc. Now let's see the other example here. In place of R, we are using CH3. Here we are using CH3. Here it is given CH3. When we use CH3, it gets one name. Let's see the same, but in place of R, we are using CH3. Here the same bromines, the same carbons. Now let's see the name. All are connected with single bond. It indicates it is a ane. Total how many carbons? 1, 2, 3, 4. Total 4 carbon. So it is So it is butane. Now, why we got the bromo? Because of bromines, bromo. How many bromines? 1, 2, 3, 4 bromines. So tetra. Now let's see where the bromines are. You can see on second carbon, 1 bromine is here, 1 bromine is here. So 2, 2. On third carbon, 1 bromine is here, 1 bromine is here. So 3, 3. So total the name is 2, 2, 3, 3. Because of 4 bromines, tetra, bromo, butane. So when this reacts in the presence of alcoholic potassium hydroxide, in the presence of zinc powder or zinc dust, the single bond between these carbon will form into triple bond, and the bromines go out, they react with the zinc and form zinc bromide. So now let's see the name. Yne, because of triple bond. But, because of 4 carbons. Why this is 2? This is first carbon. If you take this second carbon, the triple bond is starting at the second carbon. So 2 butane. You can count from this side also. 1, 2, 3, 4. Even though from this side you count from left side, again it comes from second carbon triple bond. If you count from the right side, it comes on the second carbon. So the name is 2 butane. So now like next one. Properties. Alkynes, they also can form series like alkanes and alkenes. They form series. The first member of the alkyne is acetylene. This acetylene is a colorless gas with garlic odor. In Somali, you know, it is a thorn. The acetylene is slightly soluble, not completely. It is soluble lightly, means little. So whereas it can be dissolved completely in organic solvents like benzene organic solvent, alcohol organic solvent, acetone organic solvent, ether organic solvent. In organic solvents, acetylene dissolves completely. Now acetylene is lighter than air, not heavier. Lighter means not heavier than air. So in the form of gas, it can be easily out. Alkynes are flammable, means easily they are combustible, easily they can burn, they can catch fire. Now if you see, when they burn, alkynes, when they burn, they release smokier flames which is having dense black color smoke. So they give more smoke than alkanes and alkenes. If you see the chemical reaction, alkynes are very reactive compounds. Why they are very reactive? Because of triple bond. So this triple bond, because of triple bond, this triple bond consists of two weak bonds. If you consider this as weak and this as weak, and middle one will be strong. So two weak bonds and one strong bond. Weak bonds are called as pi bonds and strong bond is sigma bond. So it's advanced study. Weak bond, pi bond, weak bond, pi bond, and this strong bond is sigma bond. So it is very easy to break these pi bonds. It is very difficult to break this sigma bond. So very easy to break the pi bond means that's why they are very reactive. The alkynes are very reactive because of pi bonds. So alkynes react with other substances. Two weak bonds are readily broken one by one, either from this first or this first, or from this first or this next. Then what happens when pi bonds are removed? Addition takes place. So these bonds go out, they form single bonds with some other elements. So those reactions are called as addition reactions. So alkynes can also undergo addition reactions like alkenes. Now let's see addition of halogen. Halogen, you know, X, the elements of 7th group. Fluorine, chlorine, bromine, iodine, acetylene, those are halogens. Now chlorine, here we are going to take chlorine and bromine. When they add up to acetylene, they form tetrachloroethane if we consider chlorine, tetrabromoethane if we consider bromine. When bromine water is added to acetylene, what happens? Bromine, which is red brown color, acetylene is having triple bond. When we add bromine water to acetylene, the bonds, triple bond will break. The bromine water is discharged rapidly due to the formation of colorless tetrabromoethane. It means acetylene is having triple bond. When you add bromine to this triple bond will break and they form into single bond and they form this compound tetrabromoethane. The tetrabromoethane is colorless, whereas bromine is red brown color. Now let's see the equations here. C2H5, it's alkyl, and here hydrogen. Here you can see having triple bond, it means this is alkyne. When you add HCl, hydrochloric acid, what's happening? This is reacting here. So triple bond is changing into double bond. So you can see here for this carbon here, and you can see one chlorine here and one hydrogen here, and the chlorine here, hydrogen is. So triple bond is changing into double is changing into single on addition of HCl, more HCl. Again, see this compound having triple bond. When you add hydrogen bromide, it changes to double bond, then double bond again on addition of hydrogen bromide. This double bond is changing to single bond. If you see again here triple bond compound, on addition of bromine, it's changing to double bond. You can see here and here the bromine are attached. Again, on addition of more bromine, all are changing to single bonds. Here if you see alkyne, so you can say ethyne. So triple bond here. When you add iodine, less iodine, so 2 iodines join here. Again, on addition of more iodine, what happens? Single bond is formed. It means you can see 4 iodines, 2 hydrogens. So the next part, oxidation with KMnO4, potassium permanganate, ethyne, which is an alkyne. When it is oxidized by alkaline KMnO4, basic KMnO4, what happens? 4 hydroxyl groups add to the triple bond. Let's see what's happening here. Cleavage means breaking of alkynes to carboxylic acid. Alkynes convert to carboxylic acids. You know the carboxylic acid having functional group COOH with KMnO4, means in the presence of KMnO4. Now let's consider this as alkyne showing triple bond in the presence of potassium permanganate, KMnO4. What's happening? See here R1, see here R2, they are separating. OOH, the middle is C, COOH. It is one carboxylic acid, it is another carboxylic acid. So now let's see here the alkyne, same here potassium permanganate. So what's happening? One carboxylic acid, another carboxylic acid. Now let's see the another process here. On potassium permanganate, more potassium permanganate when reacts with ethyne in the presence of water, what's happening here? The triple bond is changing into single bond. The OH here they are attaching, here they are attaching OH. So what's happening? On addition of what is happening? The MnO2 is going out, KOH you can see here. The water is removed. When water is removed, it is leading to COH, and this one is leading to COH. It means some are adding, some are removing. Some on addition, some on removal. What is happening at last? Glyoxal. This is the glyoxal. This is nascent oxygen. When nascent oxygen is added to the glyoxal, the last oxalic acid is formed. So what's happening here? You can see here for this H, the oxygen is attached. So this is oxalic acid. So only the difference between glyoxal and oxalic acid is the O here. So the next. Uses of acetylene, where we use the acetylene. Acetylene produces oxyacetylene flame with oxygen, especially in welding purpose, because of when acetylene releases when acetylene produces this oxyacetylene flame with oxygen, lot of energy, means exothermic energy is released, exothermic reaction, heat is released out. That because of that heat, this is used in welding purposes. You know, in the welding, iron, joining two iron parts or two other parts of iron, we use this part. Acetylene is used to prepare other chemicals like alcohols, acetaldehydes and acids. And how the fruits ripen? Natural ripening of fruits is because of phytohormone which is present in plants, this is acetylene. Normally and artificially also we can use this ripening of fruits. This acetylene used for the manufacture of polymers. Polymers means having many units like PVC pipes, polyvinyl chloride, polyvinyl acetate, and synthetic rubber like neoprene. They are prepared from acetylenes. So it is polymerized. The acetylene is also polymerized, means polymerized, many units of many number of acetylenes when they join, that's called as polymerization. The polymerized, when acetylene is polymerized, benzene is also formed, which is used as a raw material for the variety of organic compounds. So we conclude the topic here. So stop the topic here.